Hello, welcome to BioExcellence Tutorials. In this video, I'm now going to show you how we get the relationship between the unit vector in position and the unit vector in rotation. In the previous video, we managed to derive or to come about the unit vectors in the polar coordinate system. So now we're going to look at the derivatives. How do we get the derivatives of these unit vectors in polar coordinate system, which at the end gives us the relationship between the two? So when we have that dot on top there shows that it has been differentiated. The unit vector has been differentiated with respect to time. So it means we have unit vector with respect to time. So now what you have to understand is that these unit vectors now are in polar coordinate system. It's not the Cartesian coordinate system. So we can substitute here where we have change in t. And then our position is unit vector in position is this theta j, like that. So you are going to see that here we are differentiating the rotation with respect to time, but we have a theta here and we have change in time here. So we can manipulate something here on the operator. We can manipulate the operator so that we can be able to differentiate that theta, or we can differentiate cos theta and sin theta. Now, how do we manipulate the operator? So we are going to introduce a 1, okay? Before the equation, we're going to introduce a 1 in form of change in theta with respect to change in theta. So what I mean is we are going to introduce change in theta with respect to theta, and this is 1 basically, and then we have that. So this is a little bit of calculus. This is a little bit of calculus. So we're going to see that we can swap the denominators, of which we are going to have change in theta with respect to time, and then here we have change with respect to theta. So like this, we can be able now to differentiate cos theta and sin theta. So once theta is differentiated with respect to time, we are going to put it theta dot, shows that it has been differentiated with respect to time. So there's a dot here on top of theta. And then when we differentiate cos theta, the derivative of cos theta is actually negative sin theta. And the derivative of sin theta is positive cos theta. Okay. So when you look at this part here, when you look at this part, you are going to see that this is actually a unit vector in the rotation, okay, which we found here. So we substitute that with the unit vector, and we are going to have the derivative. Okay, so we're going to have that by the unit vector. So this is where the relationship is coming from. So we go on and do it as well for the unit vector in rotation. So it also means that this has been differentiated with respect to time. Okay, so we substitute time, and then we substitute with that negative sin theta I plus cos theta j. Okay. So we do the same we introduce a 1 in form of theta. Then we're going to have that so this which we are deriving here is going to help us to find velocity and acceleration in polar coordinate. A lot of people get confused. Okay, so we swap the denominators. Okay, and we have that. So this is going to be theta dot, and then we differentiate this. Once we differentiate negative sine theta, what we're going to have is negative cos theta. Negative cos theta. And the derivative of cos theta is actually negative sine theta. So here we are going to have negative sine theta. And we have a j there. So we can factor out a negative here. Can factor out a negative and remain with cos theta plus sine theta. And then we see that this part here, this part is basically the unit vector in the direction of the position. So we have that is negative at multiplied by the unit vector. So the relationship we have here is the derivative, okay, of the unit vector in direction of position is given by that, and is given by negative theta. So this is where these are coming from. So once you understand here, then you are not going to have difficulties in deriving velocity and acceleration. Have you found this video to be helpful? If you have found this video to be helpful, kindly give it a like, share it, comment, and also if you have not yet subscribed to the YouTube channel, kindly subscribe to the YouTube channel and click on the notification bell so that you get notified each and every time I upload a new video. So in the next video, I'm going to show you how to derive velocity and acceleration.